for assignment 4.2 recommender system. I've done it using Python and using classes. So first we have a function put book info, in which we have hard coded our inputs. Train set and test set are basically, train set is the first 30 inputs from the user ratings, and test set are the last 10. Pearson correlation function finds the Pearson correlation coefficient for the given inputs. It's a recursive call for each input given by another function, which we'll see in a bit. Our main functions include KNN, predictor, recommender, and mean absolute error. So first we'll talk about KNN. This function is used to get the k nearest neighborhoods for a test user. It iterates through a a user matrix passed to it to calculate the Pearson correlation between the user in the given matrix and the test user. Then these correlations are stored in another data frame where they are sorted in a decreasing manner. The nearest k neighbors are then returned from the KNN data frame over here. Next function is the predictor function. The predictor function is used to predict the ratings for a given user for a given item. The user is dropped from the test set and a new set is formed to store the remaining data. Then the KNN are extracted for this new test set and the new user rating matrix. Then the k nearest neighbors are iterated to get the count on the similar items and also their similarity, which we have done using the function formula given to us over here, where this is the similarity and this is the similar items. Yeah. Once this is done, we put everything in rating and calculate the rating, which is then returned. Next function is the recommender function. The recommender function provides the top n recommendations for a given user. As you can see, it takes in the user number of recommendations, k, and book names. It checks if the value is 0 or not. If yes, then it proceeds to predict the ratings one by one. It then compiles the rating and returns the top n recommendations, as you can see over here. The next function and the last function that we are going to use is mean absolute error. As the name suggests, it calculates the mean absolute value, which is mean absolute error. It gets the correct rate and the predicted rate and then returns the mean value over here. Using this, we have like mean absolute error plot as well. I won't go through it, it's a little bit big. So first I'll show you the graph and the plot graph of MAE that came for me. This is our basic graph, and since it takes a little bit longer, I'll just show you the first this thing and then I'll rerun it again. These are the mean absolute error with k is equal to 5, we got this, and for different k from 1 to 30 we've got this mean absolute error values over here. It takes like around 6 to 10 minutes to show up, that's why I just showed you right now. I'll just start it from the beginning now. It takes some time to compile, and there you go. User 35's 10 nearest neighbors with their similarity, pretty good one. User 39's 10 nearest neighbors. User 35's predicted rating for item 0, for item 6. These are all rounded off, that's why they're whole numbers. Top 3 recommendations for user 35 is this, user 36 is this, mean absolute error is this. Now when we come to back to the code, you would see that I have put in the location as 4 for the test set for 35 and 8 for 39. This is because in the test location it starts from 0 to 9 as shown over here. Yeah, as you can see over here, it's 0 to 9. So